This is TWIS. This Week in Science, episode number 1065, recorded on Wednesday, July 1st, 2026, lighting up the skies. I'm Dr. Kiki, and tonight we will fill your head with Spudcells, Planigales, and Snails. But first, thanks to our amazing Patreon sponsors for their generous support of TWIS. You can become a part of the Patreon community at patreon.com/thisweekinscience. Disclaimer, disclaimer, disclaimer! I missed a view of the strawberry moon because it was overcast in Portland last night, or 2 nights ago. Whatever. This wasn't such a surprise for a night at the 45th parallel. What do you see when you look up? Clouds? Pollution? Or clear skies and stars? What if that view were filled with satellites instead? If your long exposure telescopic images were streaked from right to left, crisscross, and upside down, how many launches will it take to fill the night sky? How many lost fireflies? Will the endangered be missed when we have their genome frozen in a dish? How is the view? On This Week in Science, coming up next.
I've got the kind of mind that can't get enough. I want to learn everything. I want to fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I want to know what's happening. What's happening? What's happening this week in science? What's happening? What's happening? What's happening this week in science?
Good science to you, Kiki.
And a good science to you too, Blair, and everyone out there. Welcome to another episode of This Week in Science. We're back again without a Justin. It's just me, you, and the science.
Did he ever even exist?
I don't know. I mean, I think he's like a Sasquatch now. The question, will he ever be witnessed again? You must stay up late in the darkness. Watch him fall asleep on the couch. I don't know where he is these days.
I don't even know if he does that anymore.
I know. We have no clue. No clue at all.
Someday we'll have a guest, Justin, on, and he'll get to catch us up.
I think it would be great.
Yeah.
Did you see the strawberry moon this week?
No. All of the curtains and blinds in my home are closed long before the sun goes down. So I didn't even know that was a thing. Remind me what a strawberry moon is?
So the strawberry moon was very strawberry colored. That people have pictures of it from all over the place, and there were just gorgeous. There's the gorgeous red glow of the first moon of summer. However, this one is, let's see, what did they say? It's not supposed to come back in quite this same way for another 20 years. So it's a very low arc and the lowest arc of the full moon. And because of the low angle and the way the light bounces through the atmosphere and moves, it looks amber, reddish orange. And so there are pictures from all over the place
of them.
Beautiful strawberry moon. Fada saw the strawberry moon in my mind.
So without spending the whole show on this, the moon's fixed in its orbit, right? So everybody sees the same side of the moon, or it's moving. Okay, so it's like
but the orbit is not circular,
right? But we all, no matter where we are on Earth, see the same side of the moon.
Yes.
Okay. Now, because of that, what makes it pink, I guess, is my next question. Is it as pink everywhere, regardless of where you are on Earth when you see it?
Yes.
So what makes it pink?
It's our atmosphere that makes it pink. So it's It's the way that the angle of the light is coming through.
And that happens consistently no matter where you are on Earth. That part is
yes,
wild
and
to me.
so people had pictures from England, from the beaches of Italy to here in the United States of our strawberry moon, and it was very reddish orange. Some places very pink. Yeah. So it does depend on also, this is probably more of a northern hemisphere phenomenon because of summer than a winter strawberry moon for the southern hemisphere. But regardless, I never used to know about all these things, but now because of the internet and people know astronomy, and so all the time it's like, oh, it's another giant moon. It's a super moon. It's a strawberry moon. You'll never see.
I feel like before the internet, you would just go outside and you'd be like, "Oh, moon's big." Yep. And that was it.
Yes. That was
Man, did you see the moon? It was super big. Yeah, it was. So this says that when the moon is low on the horizon, moonlight has to pass through a thicker layer of the Earth's atmosphere. And because it's a thicker layer, the shorter wavelengths like blue and green are scattered, and the longer, warmer wavelengths like red and orange are the ones that reach our eyes.
Yes, thank you for being accurate about the physics of how it works. But
thank you to Google. Less and less accurate these days, but that looked good. So
that is fairly accurate. Yes. But we only have one moon.
Yes.
Technically, although more and more satellites are being put into our not our atmosphere, into Earth's orbit. And so one of the issues that I brought up in the disclaimer was that the Europeans is based on the European Space Agency publishing a study that found that current proposals to launch over 1.7 million satellites into orbit are going to really destroy astronomy, because Earth-based telescopes, even space-based telescopes, we now have streaks through the Hubble telescope. We have streaks through the Sphere telescope that is in orbit. One of these telescopes recently, it's like every image has crisscrosses. They have certain algorithms to shut off the sensor when cosmic rays hit the sensor so that they don't get overwhelmed by all the energy. Because satellites are so bright now, the satellites themselves are overpowering and triggering that response. So the satellites are basically turning themselves off when they're doing their fuzzy fixing, and there are railroad tracks going across images of the sky. And if there's anything behind those railroad tracks, we don't know what they are. So it's going to negatively influence our astronomy abilities. It's not great, and we've managed so far. A researcher, Olivier Hainaut, says until now we've managed, but it's getting worse. And it's not just SpaceX who's doing this. There's another startup, Reflect Orbital. It's a US startup who wants to put giant mirror-like satellites in the sky to make sunlight available 24 hours a day. That's gonna be interesting. But these massive, they call them mega constellations or super constellations of satellites, where they are in the orbital plane of the planet, is really growing and potentially going to create a pretty bad issue. I have an image here.
What would all these satellites be for?
Well, communications or monitoring. There are all sorts of reasons that we're putting satellites up. There's spy satellites. There are satellites for environmental monitoring. There's, the communications ones that are satellites.
Mm-hmm. Why can't we use the ones that are up there?
Because there aren't enough, and there isn't enough coverage for all of the purposes that apparently everyone has.
Man, shut them all down. We don't need cell phones anymore. I'm sick of it.
Forget about it.
Get rid of the satellites. Get rid of all of the connectivity. Just send us back to landlines and no internet. Encyclopedias. Let's just go back.
Yeah. So like the Vera Rubin telescope that has just been redone is going to be impacted significantly. I've got an image on the screen of satellites crossing the night sky from the Atacama Desert in Chile over a period of only 1 hour. The streaks are stacked, and so we're seeing all of the tracks that happen during that area. Yeah, but it's kind of the kind of thing that happens if you're tracking the sky, if you're doing a timed time-lapse observation using a telescope. All these things are yeah. So anyway, the time is now for us to have a conversation about how we can preserve our night sky if we want to not just have anybody launch into the sky and end up giving us a sky like Wall-E. I mean, we really need to go back. It's like, I think we are in the timeline of Idiocracy and Wall-E right now, and we need to pay attention.
There needs to be some international laws set for how we tarse things into space. Because you can't just, this can't be international waters, but space. We need some more regulations than that.
That's right. That's why we all need to be members of or citizens of Asgardia, our spacefaring country. But anyway, that's one story that I think is interesting going on, that we should be aware of what's not, what we can see around us and what we won't be able to see around us if we're not careful and not observant. And humanity is what we do. Like if we build it, and that's what it is. But we can stop it. We don't have to have that one. Yeah. I have other stories for the night. Do you have stories? Yes. Yeah. So this week I have news about some spuds, which are some cells that are interesting. Spud cells.
Oh, not potatoes.
I don't know why they call them. It's a synthetic whatever, but spud cells. I think it's very a cute name. Potato cells. Also, conversation about a collaboration, a partnership between the government and Colossal Biosciences, and some. I wish Justin were here. It's why I brought his name up. Some Homo Naledi news and some 4th of July advice, in addition to a few brain stories. What do you have, Blair?
Oh my goodness. I have what are they? I'm going to keep forgetting what they're called. Planigales.
What are Planigales?
It's not often that Blair, I'm going to talk about myself in the third person. I hate when people do it, but it is not often that Blair discovers a new animal that's already been known about. And that happened this week, and so I'm very excited to talk about Planigales with you guys. And then also crocodile skulls and camouflaging snails.
How do you camouflage a snail?
The rain.
What? Okay, This makes zero sense. All right. I'm looking forward to all of this. Yes. Everyone, as we jump into the show here, I want to remind you that subscribing to TWIS is the best way to keep us in your feeds, right? You want to subscribe to us on Facebook, Twitch, and YouTube, where we broadcast live each Wednesday at 8 p.m. Pacific time-ish. Additionally, you can find us as TWIS Science on a bunch of social media outlets, and you can go to our website, twis.org, if you are interested in show notes or, links to just the audio files and other great history of the show. It's been around a long time. But now it's time for the science. You ready?
Yes.
Yes. Dun, dun, dun. All right. I am jumping into things with the spud cells off the bat because I do love synthetic biology. And so this work is out of the University of Minnesota. And the University of Minnesota's research team, led by Kate Adamala and Aaron Engelhart, they're in the College of Biological Sciences. They've just published that it's not peer reviewed. So this is a weird one. They've published a paper that isn't peer reviewed yet and not actually published in a journal yet. But it's not even on archive, which is very interesting. But they have a new paper on their site that is a public benefit company that they have started with Drew Endy. And this is called Biotic. Now, Biotic they have developed, co-developed, and they're trying to make a publicly available synthetic cell and basically create all of the information for designing a cell and creating a cell from scratch in the public domain. So it's not, it is a corporation, but it's a public benefit corporation. And the idea is to make all the info available as opposed to hold it back behind closed walls, closed doors. So the Spudcell is the first synthetic cell with a complete cell cycle, or so they say. And in this cell cycle, what they have created is they took a bunch of soupy ingredients. They took a number of enzymes, a 90,000 base pair genome, which is smaller than what was estimated to be the smallest possible genome to keep a cell alive. So this is pared down even smaller. They've gotten rid of a whole bunch of things. And they've put DNA molecules that are plasmids. So there's 9 different plasmids instead of having chromosomes. They have 9 separate plasmids, each with about 10,000 or so of these base pairs, a lipid membrane, and Spudcell can grow and can replicate itself so that it is basically alive because it can replicate. The thing is, it hasn't been shown to be able to mutate and evolve. And so the materials that everything that its life depends on, it kind of relies on external feeder cells. It relies on a bunch of external stuff. When they did change the DNA, there was a DNA change. It was because the researchers did it themselves. They changed the genome. It wasn't the cell mutating. So at this point, we've got a little tiny cell that can divide and can maintain itself, but because it doesn't have repair metabolism, it doesn't have any of the mechanisms to actually repair DNA, over 4 or 5 generations, it deteriorates and will die out.
So can I ask a potentially silly question? What would we use silly. These cells for? Why? Why do we want spud cells? What's the goal?
So this is the idea to be able to create our own cells. So say have companies that we build our own bacteria to eat oil, to eat petroleum, that we create microbes that are completely synthetic to be able to produce vaccines or to produce medicines that we'd like. There are all sorts of reasons that we might want to create very specialized microbes for specific purposes. Organisms.
Does this also mean you could bioengineer like illness, like biological weapons?
For sure. Yes. Ugh. Yes. Yeah. So for instance, so any microbe-based biological weapon that we have found historically, they've been just microbes, right? That we use
selectively bred.
Selectively bred them, right? Yeah. But this is, oh no, we could actually just create biological cells that can do any function. So anything, it's how you use it.
Yes, of course.
So
Now is not the particular landscape where I am feeling trusting of those with technology in their hands, however.
I'm so sad that this is the way that you go. But,
No, it just feels like a blank canvas.
order.
Like, it
But it
feels
is.
like it could be very, very good and also very, very bad.
Absolutely. And it has the potential to be all of that. And it's going to be a tool set that eventually anybody can use to design their own little living systems.
Well, I'm glad it can't evolve yet or mutate, because that's where things get out of control.
And at this point, I think it's good that it also can't maintain itself, that it winds down after a certain amount of time, so that you know how long
Keep
it would
that.
last. Yeah, so similar to so many things, I think these synthetic, or even when we are intentionally evolving microbial species to have certain traits, whatever we're doing in our choosiness of what those traits are, even with gene drive and mosquitoes, or all these various possibilities, it's understanding what the lifetime of those things in a lab environment and in a dish versus in the real world, I think is essential. I mean, we're already outnumbered by microbes on this planet. So, I mean, adding a few more, whatever.
I suppose.
Yeah, it's gonna be great.
Wow, that's spooky to me, but I guess that's great.
It might be. That's fine. You're like, I'm not sure. We might want this. Yeah. So anyway, this is bottom-up building of a living cell from individual non-living components.
Yeah.
So taking different parts, putting them together, and creating something that is at the edge of life. And so understanding this, again, is instead of taking bacteria and taking things away to see how they're able to live and exist and not die out, and I took that protein away, oops, now you're dead. Instead of doing that, this is the other direction. And in this engineering, we can really start to answer the question of what is the edge of life. What can we really do alive? What is necessary for life? And it might also give us ideas about where life could evolve by understanding this kind of stuff. What has to be there to allow it to happen. Apparently, these needed somewhere around 83 degrees Fahrenheit to be able to evolve.
Interesting.
Yeah. And on this front of life, and as Brian Burwell is saying, life finds a way, as Justin used to be able to say so well. There's a new partnership between Colossal Biosciences and the U.S. government, and
what could go wrong?
Specifically with the Department of the Interior and the Fish and Wildlife Service. And have you heard anything about this, Blair? No.
Is this for big game hunting?
It is not. Well, I mean, that's not what it is for. Ostensibly, what is happening is that the government and Colossal Biosciences are teaming up to create a biobank. That Colossal Biosciences is going to work with the Fish and Wildlife Service to go around the United States and collect some 2,000 to 3,000 species that are potentially endangered, that are on the endangered species list, to get biological samples to be able to extract their complete genomes and have a database and a bank of biological material that would be available for, for public use if there are researchers or reasons for using it, but also could be used by Colossal Biosciences for any of their biotechnological studies and purposes.
So that was my first question, was who will technically own the samples?
Technically, Colossal Biosciences.
No.
They say it's even though it's a partnership in the Fish and Wildlife Service, and the scientists who work in the Fish and Wildlife Service in the government would be doing a lot of the work with the company. The samples would all be kept and housed and taken care of by a private company.
No.
A company that hasn't been around for a very long time, and that has, whose purposes we're still kind of scratching our heads about. And so people are saying online, or wondering online, whether or not the government can use this currently as a way to get around the Endangered Species Act, because if a species is endangered, we don't have any way to bring them back. But but Colossal is going to be bringing back species from the dead or from the brink of extinction, hopefully, maybe. So if we've got their biological material, go ahead and destroy that habitat. I mean, this is what people are saying online. Apparently, it's going to be a 5-year contract. And so what ends up happening is at the end of that 5 years, we will not know. But regardless of how this is used for political purposes, I think the scientific questions are still... The San Diego Zoo has the frozen zoo. They already have some 10,000 species, frozen samples. They're doing the genomes. The San Diego Zoo in California is a nonprofit. It is. It's not a for-profit company. It's already working with different zoos, different countries around the world to create a biobank like this. It's already in practice, and it seems like that kind of a biobank is much better for the public domain and for the actual storage and maintenance over a long period of time than something that will be held by a public company. Or a private company with who knows what happens if they go belly up? What happens
are they just going to sell it all off?
What happens if they decide? If they decide,
are there any
it's not public
accrediting
anymore?
Bodies watching how they store this stuff and who's doing regular checks and what kind of specimens do you have? Do you have multiples within a species? But there are standards of practice in the zoo community for this kind of stuff.
Yes.
And there are accrediting bodies, and there are people who come in and check on your equipment, and you have to get your A every year to continue doing what you're doing. And this is like some crazy Wild West stuff that it just feels like there's some sort of weird pocket lining going on. You know what I'm reminded of is well, that's like everything now. I'm gonna say it was the early 90s. We had a computer game that was in the near future, and it was probably like 2015 or something like that, right? Because that's always how those things work. And pretty much all animals were extinct. Okay, so pretty much all animals were extinct, and your job in this video game, and I'm going to get this not exactly right, but I think it was, you were like a pirate, and you had to steal the genome, like you had to steal the genetic materials of extinct species from other ships to then collect all of them so that you could repopulate the Earth. I'm so curious if anyone in the chat room or anyone else remembers this, but it just feels very dead on that like Colossal Biosciences has all this stuff, and then the eco pirates are going to have to go and steal all the genetic materials to actually repopulate the Earth because Colossal's waiting for the highest bidder or whatever, you know. It's they're saying that it's going to be for public use, but will it actually be, especially if they hold it?
How much access will people actually get? You know, and
are
if
you
you
gonna have
do,
to bid over it?
or are you like required to partner with them on whatever work you're doing if you want access for it? And, you know, which would mean, is whatever you do, does it give them some kind of future licensing capacity, or is
Are
there
they going to
always
own all the pandas that are born?
right?
Or
So
like,
I mean, there are
similarly,
big
is the
questions.
government going to be like, I demand that you let Colossal use your white rhinos or your elephants? Like, ugh. I don't know.
Yeah. So this is the interesting. The public-private partnerships are happening more and more. Public-private partnerships have always been a part of our federal and our governmental and public commercial space. However, just the way that things are happening now, it seems it's bringing up a bunch more questions than there used to be. And for the scientific credibility of this kind of work going forward, I think that's where, you know, I think this is, it's going to be putting things into edge cases that potentially make things less trustworthy for the public and for scientists.
And, you know, to your point, like, the San Diego Zoo is a proven expert in this field. If this is what you want to do as the government, give them your money. Not a company that has so far been selling wishes and dreams. Like, they haven't really provided much. Colossal. A lot of theories, a lot of kind of proof of concept, but nothing substantial. And so they're just handing our taxes over to this private company without really a track record of proven results in this area. So they could just be funneling them a bunch of money that never goes to anything.
Right. Yeah. Apparently, Colossal already has announced or is attempting a biovault with Dubai, where they are going to be collecting some 10,000 species. Anyway, yeah, you can look up all this stuff online. There's some great reporting about it, as well as some great conversations happening out in the wild.
Weird. Okay.
It is weird, but we need to be aware of these blurry lines and how they are moving these days. So let's move away from my really positive news from the beginning of the show. What do you have to talk about?
Do you know about Planigales?
No. What is a Planigale? I mean, do I? I
had to look up how to pronounce it because I really truly had never heard of them before.
It's a Planigale.
I was Planigales. Planigales.
Oh my gosh.
Planigales. It's Planigales. They are the world's smallest marsupial.
Aww.
They weigh just over 2 grams. That's 0.07 ounces. They say it's the same as a couple of paper clips.
Oh my
and they're about half the size of a house mouse.
So tiny.
Yes, and they
look
not
very mousy.
They're very mousy looking, and they're not super well known about because they're so small, because they blend into their environment, because apparently even Australians, these guys live in Australia, of course, but you know, random marsupial, gotta be Australia. But
right,
they live in Australia, and many Australians don't even know about Planigales because they're so effective at hiding. They can squeeze themselves into cracks and crevices. They hide from predators. They're also tiny and fearsome predators.
Of crickets and grasshoppers, right? But
insects, spiders, and small vertebrates like lizards or even young mammals.
Okay.
Yeah.
And it's in Australia, hunting spiders is no simple task.
Yeah. Spiders big as your head. Yes.
No.
So they live in pretty much wherever there's cracking clay soil in central and northern Australia. There's also one species in Papua New Guinea. But because they're so small and they all just kind of look brown, they're difficult to tell apart. And so over the many decades of studying Planigales, They're difficult to catch. They weigh so little. And they dig holes, and they have these kind of like pitfall traps. They're like hard to find or get out of their little holes. They live in remote areas. It's difficult to figure out where they are and how to get to them. And so it's been really, really, really difficult to study these animals, capture a good number of them, and study them.
Okay.
Yes, but there are about 200 years of museum specimens and data. And researchers recently combed through over 2,000 specimens so that they can see what's going on with these guys. They thought there were 4 species. Like, this is not like a super complex story here. They thought there were 4 species, but they found instead 9. And this is because of looking at the genetics of the individual specimens. In one case, there was one where there was this one outlier species that just based on physiological description, they were like, this might be a different one. And they found that and then 2 others that all fit this different genomic makeup. And so they were able to do that in a couple of different times with these specimens where they were able to identify actual species based on genomic differences. They call these cryptic species because you can identify the difference by genetics, but they are pretty much impossible to tell apart based on appearance alone. And that's why you might have this one that you're like, maybe this is a different Planigale, but then it turns out there's 2 others of that genome type that look just like all the other ones. Or look just like another species that you've already identified. And so this is an example of, the island biogeography, right? Like, because Australia is an island and you have this crazy radiation of marsupials without large predators, that marsupials just went hog in Australia and were just like, what if I did this and this and this and this? And so all these different types of marsupials showed up that on the mainland got eaten. And then so the selective pressure was less on like, how do I become bigger? How do I have bigger babies? How do I do all these things that actually push towards placental mammals? Instead, these guys were like, but what if I'm this kind of marsupial? But what if I'm this kind of marsupial? And then once you had the individual groups, okay, what if I'm this type of Planigale and this type of Planigale? And so their adaptive radiation has been less of like, let me try this. Oh, that didn't work. And it's more just like, let me try this. Great. Let me try this. Great. Let me try this. Great. And so the marsupial tree in Australia is truly bonkers. I think that's the scientific term for it. And so I just love that they went in, they looked at these specimens, they all just kind of looked like teeny tiny brown mousy marsupials. Turns out, bam, 9 species.
That's amazing. But you look at them and they're like larger groups of them, I guess, or species that kind of look a certain way. So like one Planigale has like a broader nose or face or a shorter tail. One looks mousier than another. They're like these little slight morphological differences, but it's the genetics that always give us the real understanding.
Yep.
But I can see why
Yeah.
why researchers would have been so confused for so long.
Yeah, like look at those 4.
Same.
Yeah.
They're all the same. No, they're not. They're different.
Yeah.
What is this? The Little Planigale, the Arnhem Plateau Planigale, the Kimberley Planigale, and the Cracking Clay Pilbara Planigale.
Yep.
That one is red like the clay. That's
so
great.
you say. I don't know. I feel like I could never do a study involving the phenotypes of mammals because of the color blindness. It's just not possible.
What color is it? It is brown. It is gray.
brown, and brown. Yep. They're all brown.
They're so cute.
They're really
adorable.
Cool. And the fact that they're so like ferocious.
Their babies are going to be tiny,
too.
tiny. And
They're the size of 2 paper clips and they will just
All right, not one to catch with your bare hands.
No, not at all. You'd have lots of teeny tiny little holes. Yeah, one of them, Planigale petrophila, is the one that I think they found a few, and then they were like, oh, we need to write up a new species. That means rock lover.
Oh, that's cute.
Yeah, and it was previously known from only 3 specimens. So, anyway, I don't often talk about, like, we found a new species on the show because there's not that much to talk about. But first of all, 1, go look up the Planigale, and now you know a new Australian marsupial. You're welcome. 2, good reminder of going back into the museum archives and doing some genomic research on animals.
Yeah.
And, you know, to a certain extent, who cares, right? Like, they're there. Who cares how many species there are? However, if you're going on the expectation that species cannot breed between different species, then conservation-wise, it actually is important because you don't want to accidentally cut off a segment of one species thinking it is part of another. So if you're like, we got to build a freeway, and then you look at the plan and you're like, there's Planigales here, Planigales there, that's totally fine. Just pop it right down the middle. They're both large territories. They'll be fine. But if you do it slightly too far in one direction and you're cutting off one species from the rest of the gene pool, that could be a problem, right? So from that perspective, it actually does matter to know which species are which, especially when you're looking at maps.
Which are which where?
Yep.
Speaking of maps and things in different locations, one story that Justin used to bring to the show was the story of the Homo naledi species, found deep in a cave underground. This study, they actually had to get small-boned human beings, usually female graduate students and postdocs, to crawl into the cave because it was such tight quarters. So there was a whole call for very small-boned people to go into the cave.
Small-boned?
Yes, it's small, very tiny to get, because you had to squeeze through little places to get into the cave. But they in Africa, they discovered this cave, the Pilbara cave and system, and not Pilbara, I'm sorry, that was from the last story, but the Homo naledi cave system, the rising star system is what it is. And they discovered a bunch of carvings into the sides of the caves. They found bones, and there have been huge questions as to what the individuals were doing there. The Homo naledi are a very distinct species within hominids. They are upright like humans, but much more similar in their face and their bone structure and their brain size to chimpanzees. So they have, so the brain is not, it's smaller than human brain. It is, everything's different, except they seemed like they would be more upright. So there's similarities. And so it's been kind of this question of how do they fit into the story of human evolution? Well, the news out this week, researchers were publishing in Cell their analysis of dental enamel from the teeth of 20 out of 23 individuals. They found the bones of 23 individuals, teeth from 20 of them. They were able to study the dental enamel and get genetic information about, or protein information about the individuals who were there. And what they discovered based on gene called AMELX, and the X is for the X chromosome, versus AMELY, and Y would be for the Y male sex chromosome. They discovered that there were 0 male individuals in the bones that they discovered in this cave. There's really no reason that anyone can determine, other than this maybe being ceremonial, it being a burial location. Because even if you have groups of, and it happens within primate species in the wild, you can have groups of adult women where there are many, many more women than there are males. female to males in the population. And so the males could be out. There could be a dimorphism in what they do, right? So their behavioral adaptations. So maybe the males are a little bigger and go hunting and scavenging, and the females are smaller and stay in the cave and raise the kids. Even if they were in the cave raising the kids, you would think there would be male children.
Mm-hmm.
There were only female children. No male children. And so there's no explanation so far. They haven't found any other bones that would indicate that there are males anywhere in the cave system that they have seen so far. But the lead researcher has when they started discovering this information, they called off any further digging in the cave site, because what they're thinking now is that maybe the females, the reason they weren't able to tell morphologically from the bones, males from females, there were only females in the cave. And so maybe this Homo naledi, maybe males are bigger, and maybe there are sites that we found already. Maybe we need to go into museum collections. Maybe there are bones that are Homo naledi bones that are males, that are slightly different, but male individuals that are found elsewhere, and they don't know. But what they do know is that this is, and what they've said, and this may be a little bit of hyperbole, but it's an actually interesting question. Are we looking at the first instance of us coming across a non-human intelligent species? They have markings in the cave. They have ceremonial, like the placing of the bodies, the bones, the way that they're located within the cave system. There are all sorts of indications of higher level thought. And so if we are looking at not human, not Homo sapien, but another species of intelligent life on our planet, they're wondering what the precedent is for respecting that life. So, there's some really interesting questions now. How do we go on studying the site and still respect it? How do we look at these bones of past individuals and learn more about them? But
that's interesting. I with stories like this, I always like to kind of keep both pathways active in my brain at the same time, right? So like, yes, it's possible it's a ritual. Yes, it's possible it's like a female, like a matriarchal society, and so the women were like put in a special place. It's possible that like those were all mothers, or there's some sort of special thing happening here. But it's also possible that there's something much more basal that's like more common in the animal kingdom. Like it's possible that just like in a subterranean species that has different rooms underground where they do different things, that they had a space where they put their dead so that they didn't get sick from them. Right. And then it's possible that there's something else on top of that, like that they had something going on where a bunch of women were dying all at once because of like childbirth, or I don't know, whatever, right? Like there's a lot of opportunities here to extrapolate where it's one of those things where it's like, is that it was intentional the simplest explanation, or is it actually the most complicated?
Yeah, exactly. And as Eric Knapp is saying, yes, if you can't explain it, call it ritual. And that's something that Justin would bring up on the show a lot. But that is the question. If it is falling in a particular way, is it ritual, or is it just a habit, or is it instinct? Is it how did it come about? Where did it come from? And we can't go back in time, so we have to take as much evidence as possible to be able to tell the best story possible. And at this point, there's not enough evidence. And so this is the point in time where, with this evolutionary anthropology, it's we need more evidence. you know,
Mm-hmm.
the bigger the claim, the more
Yeah, you
evidence we
need more.
need.
If we find another cave that is all female,
Yes,
then
or
you're
all
like,
male.
oh,
Yeah, yeah.
okay.
Or if we do find the male Homo naledi bones somewhere
Mm-hmm.
else, indicating, they split for a certain reason, is there a place where the male bones were put elsewhere in the cave system that they just haven't found yet?
Mm-hmm.
Like, and what would the reasoning be? What are there other, special dressings? Like with the Neanderthals, we have seen that there were special herbs and flowers, and there seemed to be ceremonial aspects that we would consider. You're like, oh, you put pretty flowers in the grave, right? Like
Mm-hmm.
that's something that we do still as a remembrance. But I don't know. There are so many questions that we cannot answer at this point in time, but the technology has gotten us to a point where now this kind of analysis can take place. And the more we dig into teeth, the dentin in teeth it holds so much information. So we have to keep looking at teeth. We have to drill teeth.
That's cool.
That's what
I
we gotta
love
do.
that.
Yeah.
Yeah.
And you know
that
there's
enamel really keeps them nice for you.
exactly.
Yeah.
Yeah. Yeah. So anyway, that's our fun Homo naledi story. And before we go to the break, I just wanted to bring up the fact that in the United States, it is going to be the 4th of July this weekend. And a lot of people are going to be celebrating this year, and as we do every year, with fireworks. In Oregon, in Multnomah County and in other areas, we have already, 2 weeks ago, they put in a burn ban. Fireworks are illegal for us to light off within county limits, within city limits. They are really limiting the use of these incendiary devices so that we don't start fires. And
Yeah.
people talk about the dangers of fireworks. I just today saw a Washington state story. A house in a suburban neighborhood blew up. 700 pounds of fireworks blew up and kept popping off and firefighters were injured, people were injured. The house is just gone. So I don't know why anybody would put 700 pounds of fireworks in their house, but it was an impressive explosion. But for the fireworks that we love doing wherever we are, if we can be safe about it, there's a lot of risk to fire in the United States right now. And I think that is the biggest concern at this moment in time for me and for many other people. Because of drought, because of reduced snowpack, we have increased risk of wildfires in the West, throughout the West, in the North, also in the South, across Texas into Georgia. Louisiana, sorry, not Georgia, Texas, Louisiana. A lot of increased risk across the country, and improper use of incendiary devices can trigger a lot of fires. And in case you were wondering, what day of the year actually has more wildfires than others? I think you want to look at this picture. I'm trying to get I want to put this. Won't move it to another tab. So you're going to look at this in the screen where I'm reading the story, and there's one date. One date where U.S. wildfires caused by humans spike, and it is July 4th. Higher than any day of the year. And this is from work researchers put together years and years of data of wildfires and them being sparked. So if you're going camping, be aware of the wildfire risk. If you're going out into fields, be aware of the wildfire risk. If you are doing anything, be aware of the dryness. climate change has shifted things. And as much as we love to be nostalgic and go, why can't I do my fireworks? I love fireworks. I would prefer not to have wildfires over you getting to play with your fireworks.
Well,
Just saying.
It's also a day to lose fingers. So it's
I mean, that's another one. It's everyone's dogs being unhappy.
Yes,
veterans being unhappy.
I just saw a post the other day that said,
yeah,
this is the last work week that some people will have 10 fingers. Which, like, we just need to be done with this. Just let the professionals do it. I'm sure there's a fireworks show near you.
And I love going to see professional fireworks. They're big and they're, overwhelming, and you get to choose when you leave.
They have fire safety protocols.
Yeah. They do. And now if you don't like those, now there are laser light shows and drone shows, and there are lots of opportunities for different celebratory but still exceptional experiences that aren't going to have you lose your toes or start a fire. Yeah.
Yes.
Yeah. Yep. Anyway, in 2023, 32,000 fires were started from fireworks across the country.
That's so many.
32,000 fires. And some of them became massive conflagrations. Anyway, be safe, everyone, all right? Enjoy your weekend. Be safe. Use your smarts. Think about science. This is This Week in Science. Thank you so much for joining us for another episode of this science-y show. I hope you're enjoying it. And if you do enjoy this program, please consider helping to support us in an ongoing fashion. Head over to TWIS.org and click on that Patreon link. People who support us at $10 or more every month are going to be getting their names read at the end of the show. Yay! It's really wonderful. I love reading all your names, and I'm sorry if I mispronounce them occasionally. I do my best, but I stumble. And we have people, you get other wonderful gifts. As there's merch going out to a couple of people right now, people who have recently joined as supporters of the show, and I really appreciate your support, helping to keep the lights on, the bills paid, for making sure, as the costs of everything go up these days, that we can pay for bandwidth and pay for computing time and maintain this time for doing the show. And additionally, if you are not interested in a Patreon, there's a link there for our Zazzle store, where you can find all sorts of great TWIS goodies, most of them made by Blair. A lot of her art on a bunch of cool products. And again, all of it goes to support TWIS, and the Zazzle stuff, you can show your love for TWIS in the public. Thank you for your support of TWIS. We really cannot do this without you. Now we're going to come on back, and it's time for the show we all know and love. Not a show. It's not its own show. It's a part of the show. She has her own show too. Oh my gosh. But it's time for Blair's Animal Corner. Blair.
She loves our creatures, great and small. Biped, millipede, no pet at all. You want to hear about animals? She's your girl. Except for giant pandas and squirrels.
What you got, Blair?
I have crocodile skulls.
Well, that sounds fun.
Yeah. Crocodiles, alligators, caimans, gharials, they are all part of the crocodilian family. What do they look like, Kiki? What do the skulls look like?
What do they look like?
Yeah, what do they all what do all crocodilians have in common? The way that their face is shaped.
It's long.
Like? Yeah.
And it looks like it looks like a Planigale. No.
In a way. Yeah, so I mean,
they're
all
long
crocodilians,
and pointy.
yeah,
they have like the skull area and eyes in the back and a very long mouthy snout.
Yes.
with lots of teeth.
Absolutely. So they're ambush predators. They have their eyes and their nose on the top of their head and their ears. They're all up there. So they can be submerged except for those items. And then they have their snout is very long. And in some specific groups, it's kind of more thin. Like gharials, it's super thin. And then alligators, it's kind of more wide, more A-shaped, right? But they all kind of have that similar shape to their skull. And because they're all related, it would be very easy to assume that they all have a common ancestor with a skull that is that shape.
Right. Some reptilian dinosaurid, right?
Well, they're archosaurs, so they're related to dinosaurs and birds much more than they are to lizards and snakes. Everyone always thinks that crocodilians are related to lizards because they look like lizards just in the way that their body is shaped. But if you look at like their heart and their lungs and also their brain, they have way more in common with birds than they do with lizards. All that aside,
I know this, and I think
I know I'm helping. I'm telling everybody else. I'm not telling you. You know. But lo and behold, some imaging and some genomic investigation tell researchers that in fact this shape evolved a bunch of different times, just over and over and over and over and over. And so there's just a bunch of different like convergent evolution of this shape showing up over and over in crocodilian ancestry. And so they were able to identify unique features that distinguish specific groups of crocodilians. And so then they could kind of group everyone together throughout evolutionary time, including modern day crocodiles, alligators, gharials, and caiman. What's also interesting is that their brains almost identical throughout evolutionary time. Despite changes in environments, despite changes in skull forms, their neuroanatomy shows no change. Pretty much no change.
Amazing.
Yeah. So the crocodile brains have been conserved pretty well over the last 100 million years. They found what was successful and then they stuck to it. I actually think this tracks super well with what we know about crocodilians and what we keep learning about them. They're super smart. They're super social. They can plan ahead. They can use tools. They have so much going on that like they found this good brain plan and they stuck with it and just kept getting smarter and smarter in the last 100 million years. And that's why they're just so good. The certain endocranial features, the brain, the inner ears, show a phylogenetic signal. So they can actually look from there to see what species are closely related to each other. And they see more similarities there than in the more distant species. So this is where they can start to do their groupings really well. They were able to do this all without destroying any historic specimens, which I think is really cool, because they did that through some imaging. And so that's another cool thing where they were really able to get like inside the structure of the skull without chopping it up. They could see the inner ear without chopping up the skull or damaging it in any way, really. So that was particularly interesting to me as well. So they combined fossil evidence with modern imaging technologies and then some genomic studies as well. And all of that together, they were able to figure out this information, do these groupings, and then learn that this face shape just kept happening over and over, but with the same brain, basically.
But groupings of kind of the face shape. And so like more pointy or less pointy, but then they all have the same brain.
Yep.
Huh. So if that's the case, we've heard stories of crocodilians climbing trees.
Yes.
Protecting their young.
Yes.
Being really smart, right?
Yes. Yeah.
But we don't really hear about that with, say, gar, or people don't talk about it with alligators, right? Why do you?
Yeah.
It's the same brain.
Well, I can
I mean,
tell
it's
you
how the
this.
structure allows for different behaviors, but it's how you use it, right? Or where you are and how you
Yes,
use it.
and I think also crocodiles are probably there's probably more research on crocodiles than any other
Okay, so
groups. There's
that's
just
what I
more
would,
of them.
yeah.
They're in more places where other research is going on. They're in really easier to reach areas comparatively
Mm,
than where you might find a gharial. There's only 2 species of alligator on the planet.
mm, okay.
And they're both endangered, so like, it's but crocodiles dime a dozen. They're everywhere. So I think that's part of it, is just kind of a
That
bias based on what's available.
that totally makes sense.
Yeah. Yeah. But yeah, I love crocodilians. The more I learn about them, the more I see how they're, in so many ways, they're just like modern day dinosaurs. In some ways, they're the closest thing we get to seeing what a dinosaur looked like in modern time. The more we learn about them, the more conserved we find a lot of their aspects are. Perfect example here, their brain. It's basically a dinosaur brain, unchanged for 100 million years.
Right. Whereas the bird brain it has changed.
Yes.
Even though they come from, they come from the dinosaur lineage, and we talk about birds being just evolved dinosaurs. They've evolved more and differently, especially because of the three-dimensional, like in space flying around activity they do. But
yeah, and crocodiles are still doing what they did back in dinosaur times. And the other thing that I'll mention too is that their fossil record is really rich because they're large, they were plentiful, they have pretty robust skeletons, and they were found all over the planet. Now, crocodilians mostly found along the tropical band of our planet, but they were all over before. They were truly successful in every biome that had things that they could eat. And so now they've kind of narrowed down to the center of our planet. But when you're looking for fossils, you can really find this diverse history of crocodilians across the world in different environments. So
okay, so what this tells me, as the climate changes and our planet heats up, the crocodilians are going to do great. They're going to expand again, just like mosquitoes.
Yeah.
And cockroaches.
I would rather see a crocodilian than a mosquito or a cockroach. So
but
works
it's going to happen. All right.
Oh, and okay, so my last story, I was like, why are you looking at me?
You got one more.
I do have one more. This is so fun. Okay, so it's so fun because I am simultaneously super excited to tell you about this and like in awe, but also once I tell you about it, you're going to be like, well, duh. There's camouflaging snails, you guys. Did you know this? So camouflaging snails. When you think about like a shell, you think it's static.
It's brown. It's a brown shell. Like, yeah.
It's hard. It's like calcified, got some keratin involved. It's like it's a hard static piece of this animal. And so it's easy to assume that whatever color it is the color it is. End of story. However, this is a study from the University of Tokyo. They wanted to look at stripy tree snails. They're from the Philippines, and then they were also looking at a species from Japan. They both have found that they have dynamic camouflage. They have light patterns on their shells, but in the rain, they vanish. Their shells turn a dark brown, and they look just like damp tree bark.
Hmm.
Yeah, which I started thinking when I was reading this article about, like, I was like, man, like, did the turtles and tortoises I took care of, did they look different when they got wet? Yes. Their shells look different. They got darker.
But you never really thought about it because you weren't paying attention to that.
No, I mean, there's a certain part of it that's just like, yeah, it got wet. Like, just like if you were wearing like a light blue shirt and it got wet, it would look darker.
Yeah.
Just pretty simple stuff, but
it's more that it goes from being patterned to completely dark. So why would it shift to being completely dark and not having a pattern anymore?
And this is where the story comes in, because they wanted to figure out what mechanically was happening. So the outermost layer of the snail shell is porous. When water fills the holes, it's changing how the light bounces off of it, making a second, darker layer of shell beneath more visible. So two things. One, the structure on the outermost layer is porous. Two, there is a secondary layer that is darker than the top layer that is patterned. Of course, this has applications for some sort of materials that we could create, I don't know, camouflage for humans or robots, or I don't know, if you're making artificial shells for animals in rehab. I'm not sure. But
here, little snail, we want to make sure that your prosthetic shell works for you.
So they in theory, you can create a smart material that reacts to humidity without a need for external power, because structurally it's having a reaction to the water. What's really also interesting about this is that they found this dynamic camouflage in two different species that are located in completely different places on the planet, in the Philippines and in Japan. This intrigued researchers because it used the exact same method of dynamic camouflage. It seems like this evolved independently, because they are only distantly related, and because they're geographically far from each other, and shell colors and patterns were not related at all. And so as far as they could tell, the common ancestor does not have this ability. And previously, the assumption was that shell colors and patterns were fixed, right? So this is kind of the unexpected result of that. But again, like, I keep thinking about animals I've seen get wet and looking darker or less patterned. Like, this is not the first time I've seen this. This happens on bearded dragons. They have keratinous scales, but they're a little softer than like a skink that has smooth scales where the water just kind of beads off, right? So like, if anything's at all porous, this is going to happen. I want to know how widespread porous shells are. Is it in more snails? Is it in
probably very
all
widespread
turtles and tortoises, right? And then is this something that has a common ancestor super long time ago, or is this just a side effect of the keratin blend that they have in their shell that is, causing this to happen? So I think there's a lot of different possibilities here. Also, like, the shell makeup of a tortoise is very different from the shell makeup of a snail. So chemically, they're different. And I understand that. But I think that it's a good question of also, like, chicken and egg. Like, did they get wet and look different and then, oops, that's good? Or was there selective pressure for this, right? So I think that's the other question, is like, happy accident or evolutionary direction?
I think that's an interesting question. Also, I mean, is it because of the way that, are they more likely to be predated after a rain? The way that the light looks in the understory, how does that change? Right. So there's some interesting questions that experiments that need to be done. I
Right.
think.
No, for sure. Yeah, they need to see how advantageous it is because they're saying that it looks like wet tree bark and therefore would be helpful.
Yeah.
But would it? We don't actually
I think
know
so.
that.
I mean, if the tree bark is dark and you're still looking like a tiger or a cute leopard, right? Or just spirally and white and creamy lusciousness, then you're going to be seen. So I wonder if this is, similar to other adaptations that we've seen for coloration in different animals.
Well, and then like our other gastropods, do they do this too? Our mollusks that are in tide pools, do they dry out and look different than when they're wet? Does it match better the tide pool itself when it's dry? So I think that it's funny because it's not active camouflage like in an octopus, right? Like they're not seeing something and going, I want to look like this, or responding to something. And, it's not a, hey, some sort of signal is telling my body to do this thing. It is completely passive. It is the fact that when their shell gets wet, it looks different. And so much of camouflage, dynamic camouflage, is focused on this, like, I'm not going to say intentional, but like cause and effect based to match their environment of like, oh, I'm a chameleon and I moved from this green tree to this brown tree and now I'm brown. Or, as is often the case with chameleons, I'm mad and now I'm a bright color.
Or an octopus. Beware of me.
Yeah,
Yes.
I'm going to hypnotize you or whatever it is. But this is just, I got wet and I look different now. Like it's much more passive. And I think that not enough research has been done on dynamic camouflage that is, if I can say that, if that would be the appropriate term, that is passive, right? Because I think that that's such an excellent built-in protection where you don't also then have to spend energy. Like it takes physical energy
just happens
to exert the change when you're contracting a chromatophore. Like that takes ATP. So like this does not. That's a very cool type of camouflage I haven't really looked into that much. But like I said, it's like there is a little bit of a well duh about it.
Like, oh gee, I've seen that all the time and never thought about
and now
why.
it's dark. Like, oh yeah, things do that. But not all things. Huh.
Exactly. So let's figure out if this is different. How does it work? Why is it there? So now the why is really what needs to happen to understand it better. But they're already looking like at possible ways that we can use this for physical applications, which I think is great for us as humans. But but why?
I would prefer it wasn't camouflaged robots, but that's just me.
I'm sure.
Yeah. All right. What do you got?
I got a couple of stories for us this evening. My first one has to do with menopause.
Oh, gosh.
Yeah. Oh, joy. So what do ovaries do after menopause?
Oh.
What happens to them? Why do ovary after menopause? Yeah. So
isn't that what the menopause is going, shut it down?
Shutting it down. But then what happens to it? What is going on there? People have thought, well, it's not there anymore. What is it doing? It's not producing hormones really anymore. It should have lots of signals of cell degradation. It should be basically the common thought has been that when a mammal's reproductive period is over, that it just ceases to be important, and it was just like either an empty shell, or it would have had a bunch of non-dividing or senescent cells, right? Cells that are ready to die, or in the last stage of their life. And so a research team at Northwestern University's Feinberg School of Medicine has just published a study in Molecular Human Reproduction looking at ovaries of old mice and also ovaries of old women. And, and by looking at them, they first realized, digging into the ovaries, they're like, they're not as senescent as we thought they would be. They actually had active cells, and it didn't. And there's a quote in the article that's in science.org. The researcher in charge, who was joining this National Institute of Health effort to study all these senescent cells, she was like, oh, gee, I'm super bummed to be looking at ovaries that are essentially non-functional. So she was excited to be looking at dying cells, but not. She was like, oh, yay, joy, non-functional ovaries. Anyhow, looking at ovaries from older women, they basically found that they didn't fade away into obsolescence. They changed the proteins that were active. And so they went, what's going on here? And then decided to take a look more closely. Looking in mice, they were able to find that the markers that they found, they were no longer related to reproductive function or with egg and steroid production, or that had diminished with age among the mice, but it was different kinds of immune cells than what's typical in younger mice. And so they had immune cells that release pro-inflammatory proteins. They had immune cells that were releasing immune molecules that could be traveling to other parts of the older mouse's body. And so the question is, do the old ovaries become part of the immune system and carry out immune signaling, or are they just continuing this like aging process of pumping out inflammatory immune molecules? And so is that part of the senescent process? And so we don't know the answer to the question. We don't know whether immune cells, they're asking all sorts of questions because this is a whole new idea. They had no idea that there was any immune relation to old ovaries. And so is there a relationship between older ovaries and immune-related disease in older women? If not, is that part of the reason that the ovaries are actually keeping up an immune function that wasn't really there before? This is a whole new idea.
So I think it's interesting they did mice and humans.
Yeah,
because mice largely die after reproductive age.
Yes.
And humans do not.
So that, I think, is one of the drawbacks to using mice. But because the reason they did use mice is that they do have a menopause. Their ovaries shut down in the same way that human ovaries shut down, and they don't die immediately after the ovaries shut down.
Right.
I mean, they only live for 2 years.
Yeah.
So yeah.
But if you could look at the two sets, I think that would be really interesting. Look at a mammal that largely dies after sexual abilities disappear. Well, not sexual, reproductive abilities, sorry. But then also look at like various monkeys and primates. Lots of primates experience menopause, and the grandmothers help care for their grandchildren, right? And so there's that whole hypothesis, the grandmother hypothesis of why these animals live so long. It's to care for their grandchildren, right? And help usher their genes along to the next generation. And so I think it would be really interesting to compare and contrast those two groups of mammals, because I think therein you would see the real key in what the ovary does past menopause. Because in the ones that don't last very long past reproductive age, you could kind of wager anything, well, it's just vestigial, blah, 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 blah. Or usually they don't even live this long. So, whatever. Right. Yeah. But for the ones that historically routinely live well past reproductive age, that's where you're going to figure out what mechanism is at play in the ovary past menopause.
Yeah. And so, they did initially find this interesting trait in human female ovaries, but then it decided, okay, we're going to study it in mice because we can do more faster in mice and probably get more ovaries than if they were going for
You have
people.
to start somewhere,
So
for sure.
you have to start somewhere. And so there is this they've found all these immune cells and immune proteins, and they don't know where they go, what they're doing. And the question is it the same in humans? We don't know. Is it having the same function as in humans? We don't know. But like you said, we got to start somewhere. But yeah. Is
That's
the
so cool.
ovary
Yeah.
a super immune organ after menopause? I mean,
That's crazy.
It's crazy.
I don't know. And then also, like, what happens when women have to get a hysterectomy and then they remove the ovaries? I know sometimes that's not part of it, and sometimes it is, and it depends
Yes.
on what exact
what
procedure
extent.
you're having. I'm painting with a broad brush, but sometimes you do have your ovaries removed, and when that happens, is there an immune deficiency as a result?
Not just hormonal.
Yeah.
Is there some other shift or something that maybe we have thought was a hormonal shift? Is it actually specifically an immune shift that we just hadn't considered previously?
Yeah.
Because that's not supposed to be part of the ovary. Yeah. Anyway,
I mean, we're
lots
still
of new
figuring
questions.
stuff out about our organs. This is not just female anatomy. Like,
Yeah.
we're still learning so much about the human body. It's truly astounding.
And I think that's the great thing, is like, wow, this researcher was like, I was just thinking I was going to be looking at dying ovary tissue. But instead, I found something that was very alive, just in a different way than we had expected. And so
cool.
now there's new questions about what's going on there, which we always love new questions. I think that's one of the great things. And then finally, my last story for tonight is a story that is just, it's kind of blowing my mind, but it makes absolute sense in the way that it would work. And so this study is published in Communications Medicine, and it is in relation to brain-computer interfaces and minimally conscious or people in vegetative state. And what the researchers went in understanding was that there are a lot of people who are considered to be in a vegetative state who actually have more consciousness that nobody's noticed because of various measures. And so they are locked into their brains, and nobody knows that they actually have a certain amount of consciousness available. They're in there, they can't respond. And so these researchers, they used brain-computer interfaces to record EEG recordings from the scalp. They're simple, it's a small headgear, basically, EEG, but they used feedback to the patients. And so the way that, if you've ever used a brain-computer interface to do behavioral feedback for yourself, like there was this whole period of time where people were excited about using these computer interfaces. You put a headgear on and you could use it to learn how to meditate, how to calm yourself, how to master your emotions, or there were all these games that you could do, just like trying to think really hard about moving a cursor across a screen or whatever. And so the feedback loop of hearing or seeing something, so in somebody who's visually capable or hearing capable, you would see something on a screen that would indicate that your brain was doing the right thing. In this case, the people, there would be a tone that was played indicating that the instruction that had been given and the brain activity that came from them understanding the instruction and attempting to do what had been asked of them had been noticed by the EEG, and that they should do it again. And so over time, they were able to find a significant, so almost doubling the number of patients that they were able to identify as not vegetative and also improve their responsiveness over the period of the study. So this is the thing that is just absolutely exciting for me. So they had a protocol that was tested in 42 people between 17 and 73 years old, and 73% of them, when they were using these brain-computer interfaces, showed reliable, intentional modulation of brain activity when they were asked to imagine specific movements. 90% of those progressed to the phase of eliciting yes or no responses. So to the point where they were actually communicating with the people who had been thought to be in vegetative states, basically.
Wait, what percentage?
Yeah, so let's see. So at the start of all of this, they've doubled the clinical detection rate from 39% to 69%.
Wow.
So by using these really small, maneuverable, not invasive brain-computer interface systems, they're doubling from 39% to 69% the number of people who are being detected as having a minimally conscious state and not being vegetative.
Wow.
And then from there, in this study, there was 73% of the individuals in this 42-person study showed reliable, intentional brain activity modulation. So they were thinking about things.
That's amazing.
It said, according to their findings, responses became more consistent across sessions. And so by using this alongside other behavioral tests, of course, like one is not enough, they're able to like really increase the number of people who are identified as aware, so not unaware, but aware, because their cognitive activity is missed by the assessments that we currently have had. So
amazing.
It's one of the scariest things, of being in a coma. And it's I think a fear of so many people. You're awake and aware, but people don't know either. But you can't communicate. And something
they can just put a little hat on you.
That's what that's.
Answer yes or no questions.
Mm-hmm. Yeah, think about, and over time it was like, basic things like think about moving your finger. Just think about moving your finger. And they would eventually, because it's motor cortex and the thought process of it, they would detect the electrical activity after that question being asked. And over time, it got more and more consistent. And then eventually, because the power of those got more consistent, do this if you say yes, don't do it if for no. And so they were able to use it to actually communicate with people in these minimally conscious states.
Wow. That's great. See, this is where we need to go.
Yes. So I wanted to finish the show on a really positive note tonight.
That's amazing.
This is where computers are making a difference.
Yes, absolutely. This is the future we were promised.
Mm-hmm.
I love it. Good work. Good work, researchers.
That's the good stuff.
Yeah.
Yeah. So you can find this study, as I said, in communications medicine, and it's just amazing that you want this kind of a result, and it's just so exciting that they're able to work with people, and the thought that you can actually improve their performance over time.
Man, can you just imagine the families of any of these people when they were able to communicate just yes or no with them?
Yeah.
It must have been so powerful. That's so cool. Oh,
right. It's so cool.
Nice.
It's so cool. Have we done it? Have we made it to the we've made it to the end of the show, huh?
Yes.
All right, everyone. Time for some shout outs. I have so many thanks for everyone who is here tonight. Everyone who is in our chat room right now. Thank you for being here and for talking with us. For everyone who is listening and not able to be here live, you are so important. Thank you for being here. Thanks for enjoying the show. Fada, thank you so much for your help with show notes and social media. Gord, Arnlore, others who help keep the chat rooms wonderful places to be. Thank you for being there, being here, and being a part of everyone, making our community here just a wonderful community to be part of. Identity 4, thank you for recording the show. And Rachel, thank you for editing the show. And of course, thank you to all of our Patreon sponsors. Thank you to Aaron Anathema, Adam Mishkan, Alan Viola, Ali Coffin, Andrew Swanson, Artem, Arthur Kepler, Bob Calder, Bob Coles, Brendan Minish, Brian Carrington, Quist Rosniak, Christopher Dreyer, Christopher Rappin, Craig Landon, Craig Potts, Daryl Myshak, Dave Wilkinson, David E. Youngblood, Derek Schmidt, Don Mundus, E.O., Eden Mundell, Eric Knapp, Flying Out, Fred S104, G. Burton Lattimore, Greg Briggs, Jack, Jason Olds, John Atwood, John McKee, John Ratnaswamy, Johnny Gridley, Ken Hayes, Kent Northcote, Kevin Parachan, Kevin Reardon, Kurt Larson, Lon Makes, Lauren Gifford, Mary Gertz, Marjorie, Mark Hessenflow, Mark Jakins, Noodles, Patrick Pecoraro, Paul D. Disney, Paul Ronovich, Philip Shane, Pierre Velazar, Richard Badge, Robert Norland, Robert W. Farley, Rodney Lewis, Rudy Garcia, Remy Day, Sean Clarence Lamb, Shoe Brew, Stephanie Embry, Stephen Alberon, Steve Leisman, aka Zima, Sue Doster, Teresa Smith, Tony Steele, and Vegard Shefstad. Thank you for all of your support on Patreon. And if you would like to help us out on Patreon, please head over to twist.org and click on the Patreon link. On next week's show,
we will be back on Wednesday at 8 p.m. Pacific Time, broadcasting live from Twitch, YouTube, and our Facebook channels.
Oh, yes, we will. And if you want to listen to us as a podcast, just make sure you look for This Week in Science wherever podcasts are found. Look for our wonderful orange starburst logo. And if you enjoyed the show, get your friends to subscribe too.
For more information on anything you've heard here today, show notes and links to stories will be available on our website. That's at www.twist.org. You can also sign up for a newsletter. It'll come eventually.
Yes. We love your feedback. If there's a topic you would like us to cover or address, or a suggestion for an interview, let us know on one of our social media channels or send us an email. Just put TWIS in the subject line so your email doesn't get spam filtered into where, Blair?
A crevasse where a Planigale will eat it.
Oh, fearsome predators.
We look forward to discussing science with you again next week. And if you've learned anything from the show, remember,
it's all in your head.
This Week in Science. This Week in Science. This Week in Science. This Week in Science, it's the end of the world. So I'm setting up shop, got my banner unfurled. It says the scientist is in, I'm gonna sell my advice. Show them how to stop the robots with a simple device. I'll reverse global warming with a wave of my hand. And all it'll cost you is a couple of grand. 'Cause this week's science is coming your way. So everybody listen to what I say. I use the scientific method for all that it's worth, and I'll broadcast my opinion all over the earth. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 I've got one disclaimer, and it shouldn't be news, that what I say may not represent your views, but I've done the calculations and I've got